Hey, what's up, guys? This is Chung here. So today, let's take a look at 227, basic calculator number 2. And this is one of the calculator series of problems. So for this problem, there's no parentheses, and there's only two operators, which is the plus, subtract, multiply, and divide it. And there are I think in total four calculators problems in LeetCode. I think they're pretty interesting. So today, I think I'm gonna try to use a more generic way of solving this problem, so that in case there's any follow-up questions, you can still use the similar idea here. So a few examples, right? So there are like some solutions that you don't even need a stack. You can just use like several variables to track the previously operator and the values. But today, so for my generic solutions, I'm going to use two stacks. The first one is gonna store all the numbers, and the second one will store all the operators. So how will this thing works, right? Basically, a few examples here, So when with this kind of let's forget about parentheses for now. Let's only consider this four operators. So when can we calculate the previously two numbers? Right? So let's say we have 3 plus 2. Can we can we calculate this one? Probably not. It's depending on the current operator, right? So so at this moment, we have two stacks here. So the first stack is 3 and 2, right? And the second stack is the operator. At this moment, we have a plus 1 here, right? So that's the stack 1. That's the operator stack. And now we're at this multiplies here. It depending on the priority of the operators here, right? Because as you guys can see, if the current operator is has a higher priority than the top than the first one in the operator stack, then we cannot calculate those two numbers, right? So when can we start calculation? It only when let's say we have 2 plus 3 times 2, and then let's see that there's another time here, right? So now what we have another 2 here, right? We have another multiply, and then we have another 2 here, right? So that's gonna be our current stack. Now we're at this multiply operators here. Now the multiply operator is not greater, right? It's not greater than the top one, right? Then then we know that, okay, so now we can calculate the previously result, right? And we do that until we have seen so basically now we have this 2 times 2 here, right? So we just pop this 2 times 2. We have like what? We have 3, and after calculations, we push this thing, we append the result back to the stack, right? Now we only have this plus here, right? Right. So that's that. Let's say we have another 3 here, right? So now what we have a 3, and then we have another multiply here, right? Okay. So this part is gone, right? We have that. Now let's say the next one is plus 2, right? So what do we have? Since this plus is smaller, it's not either equal or smaller than the top one, right? Then we pop this two out, right? It's gonna be what? It's gonna be 12, right? Because the 3 times 4 will be 12. So now we have 12 here. We have 12. and then this thing is gone, and the plus is still not greater than the top one, right? Then we do what? We do a plus, which will be the 12 plus 3, which will be the 15, and then this is gone. And in the end, the 15 is our final answer, which is this answer, right? 3 plus 4, 12 plus 2. Uh, yeah, so that's the 15, right? In the end here, so we have a 15 here, and now we just need to do a plus 2 here. That's why we're gonna have like another plus sign here, and then uh, above 15 we have a 2 here, right? So this is the new stack. So in the end, we all we have is this 15 and 2 left in this stack, and then we have another the last plus operator here. So the total, the final result will be 17. So as you guys can see, so the key logic for this kind of problem is that we have to know basically of the priority between the current operator and the previously operators, and we can keep popping up. We can keep calculating the previous uh, tokens, as long as the current calculator is not greater than the top operator stack. Then we can keep popping those number one, number two out, and then do the calculation until we have reached the point that the current one is greater than the top one. Then we know, okay, we cannot continue. We have to look for the next one. All right, cool. So that's going to be our basic logic here. I'll implement that one first, and then we'll talk about the follow-up questions, like what happens if you need to handle the parentheses, and what happens if you will need to support more operators other than these four, right? How can we do it? Mm, okay, cool. So we can have the numbers, right, at the stack, and then that's stack one, and then we have our operators, right? Operators, that's going to be a stack two. So a few like variables here, right? So the n, we have n here, and then we have I here. So I is from 0, and then we have a while loop while I is smaller than n, right? And then we start doing. So since we have this kind of like empty strings, the first thing to handle is like this. Just if it's an empty string, we simply I plus 1, and then we just simply continue, right? So that's the first one. And the second one is always to capture the current integers, right? So to capture current integers, I just use this one. I just use the if si is digit, right? If the current one is digit, I just continue looping through, moving the cursor to the right until we have reached a 9-digit character, right? And then we have the current number. So that's why I'm going to define like current number equals to 0, and then while I is smaller than n and si is digit, right? Then I just keep updating the current numbers, multiply by 10, and then do a plus int dot si, right? So that's that, and then don't forget to do a I plus 1 here. Now we have the numbers here, right? So now let's do a nums dot append dot current number, right? So, and here we're gonna have like some else here. In the end, we're going to do a I plus 1 here, right? But since as you guys can see here, so we already do whenever this while loop is finished, the has already reached to the next position here. If we do a I plus 1 in the end, there's gonna be a double increase here. So that's why I just reverted back, so that all of the the branches can still use the I plus one here. It's a little trickier, right? I mean, you guys can do something else, but this is just how I do it. Okay, so that's that, you know. What is the else case? So the else case is that it's the operator, right? So else case means that it's, it's the operator, right? Operator, and so like what we have discussed now, you know, so the current, so SI is the current operators, and we just need to compare, we just need to compare the with the top one on the operators if the current one, I mean if the current operator's priority is equal, either equal or smaller than the top one, then we can keep popping the numbers out and do the calculations, right? And to do that, I'm going to create a few, I think two helper functions here, right? Like I said, you know, the first one is to get the priority, right? So I'm going to pass in the operators here, right? You know, if the operators in what? In plus and minus, right? Then I give it priority equals to one, right? Else if the operators in what? The multiply or divided, I give it two. That's the priority, right? And then I'm also going to create like another helper functions to help me to evaluate, right? Evaluate the numbers by passing in the number one, number two, and the operator. Okay, so if the operators equal to plus, right, and then we return num1 plus num2, right? So I'm just going to copy and paste. I'll see if this is a minus. We do a minus, right? So same thing for the time, the multiply, and the divided thing. So we have a that, and then we have a divided, right? So that's how we evaluate the our numbers here. So like I said, you know, so now we're at the that operator. So first thing to check is that while the operator is not empty, right? Operator is not empty, and the uh, the priority. So we check the operator, it's not empty because, you know, it could be empty, right? It's digits. Yeah, because if we have 2 plus 3 plus 6, you know, when we're at plus the first operators here, right? The operators is empty. That's why we need to check this one. So if it's not empty, and then we check if the priority and dot si, if the priority of the current operator is either equal or smaller than the priority of the operators minus one, right? So if that's the case, then we know, okay, we can calculate the first two numbers. So that's why we do a num2 equals to nums pop, right? And then num1 equals to nums pop here. So keep in mind here, so the first one got popped out is num2, and the second one got popped out is num1. So the sequence matters because we're gonna have like this multiply, the subtract and divide it. So we have to follow this sequence here. And of course, then we have a after popping two numbers, we also need to pop the operators out, right? Operators dot pop, and then we can just evaluate the numbers. after the evaluation, we need to append this back to this nums stack here. So we do a evaluate, right, by passing the num1, num2, and operator. Cool. So that's that. That's how we calculate the previous ones. And then in the end here, in the end, right? So now after this while loop here, what might end up in this nums and operators? If we have like 3 plus 2 times 6, so what we have in the stack will be something like this. Will be 3, 2, and 6. So and in the operator stack we have plus and the multiply, right? Because we're only doing this kind of the evaluations when there's like multiple, when there is a case, right? When the current one is smaller than the previous operators, right? But if it's always increasing the priorities, we might end up something like this after the while loop. That's why in the end we also need to do a while loop similar like this one to evaluate the numbers, to evaluate our our stacks. So we can simply copy and paste right here, and then we just do this. Yeah, so that's that. Oh, I think one thing I forgot to do here is that, we forgot to append the operator stacks, operators dot append as I, because the SI is the operator, right? All right, cool. So, and then I simply return the nums dot -1, because after this final while loop here, we have evaluate everything in the stack. So we can simply return the only number left. That's gonna be our answer. So yeah, I think that's it. I think let's run the code. Mm, out of index. What is out of the index? Is digits. Mm, operators. Oh, wait, maybe here. Operators. Okay, yeah. I'm missing an as here. Same thing here. Okay. 51 operators. Oh, I'm sorry here. So in the final while loop here, we don't need to care or worry about the priority here, because for all the priorities we need to be taken care of, we have already taken care of it here. So what's left here, we can simply evaluate numbers from top down here. That's why we can simply use the operators stack to evaluate the value. All right, run the code. All right, cool. Accept it. Submit. Mm, all right, so success. I mean, yeah. So that's that. The as you guys can see here, the time and space complexity. So the time is just a while loop here, right? From 1, 0 to n here, and so here, even though we might have a nested while loop here, but each element will only be pushed and popped out from in and out of the queue only once. So that's why the total time complexity is O of n, and space complexity is also, of course, is O of n, right? Cool. So that's that. And how about some follow-up questions, right? I think the the first follow-up questions is like besides this four operators, what how about to support more operators? Let's say how about this one? 3 times plus 5 times 3, and then we have a power of 2. How about this, right? Because this power operator has a higher, even higher priority than the multiply and divide, right? I think the fix is pretty straightforward because we have been taking care of these things here. You know, we have a while loop here, so all we need to do is this. It's just this. All we need to do, we just need to add another uh, another branch in the operator in the priority here. If this operator is equal to the power, right? Then we simply return 3. That's gonna be the priority 3 operators. And here we also just need to add another if condition here. If this thing is equal to that, we just need to do a right power evaluation here. Okay, so that's pretty easy. And how about to support the parentheses, right? So so to support the parentheses, you know, the we have to basically add two more else condition here, right? So the first one is simply the else if the si is equal to the left parenthesis. You know, actually there are like the way we're doing it is like we just need to add this left parenthesis to the operators stack so that later on we can we can keep popping up the operators until we have seen the left parenthesis, right? Then that we know that's when we should stop the while loop. So we just append these things to the left parenthesis to the operators. That's all we need to do when we see a left parenthesis, and more work needs to be done when we see an ending parenthesis, right? So when this thing happens, so what should we do? You know, keep in mind that so it's gonna be similar like our final while loop because all the priority related calculations, have been taken care of in this while loop here. And so that whenever we see an ending parenthesis or we have reached the end of this string here, we know that we can just safely um, we can safely do this kind of pop thing from the top to calculate that and then add it back, and then we can just do an evaluation by with those two numbers plus the operators. So that's why actually we can simply copy and paste this part, but the only thing we need to add here, is and what? And the operators and operators minus one. That this operator minus one is not equal to this left, right? We keep doing this until we have seen a left parenthesis. Then we know that's when we should stop, right? And then after this while loop, don't forget to pop this left parenthesis out. It's gonna be another operators dot pop. Yep, yep. I think that's all the follow-up for this problem. Like this is like a generic way of supporting to evaluate any of the operators including the parentheses. Cool. So yep, that's it. Okay, I think I'll just stop here. And I hope you guys enjoy watching this video. Thank you so much, and stay tuned. I'll be seeing you guys soon. Bye bye.